That's why this 2 is here, right? And then, oh, can't forget to balance it. And now this aqueous, this one is a solid. Water is always a liquid. And if you looked up MgCl2 on your solubility table, it would say this is an aqueous. So this is a double displacement. Now, let's do a net ionic with this one. So if we did a net ionic with this one, let's see what happens. This is a weird net ionic one. So let me just make this so you can see that this is an AQ right here. So you break up everything that's an AQ. If it's a solid or a liquid, you don't break it up. So if I break this up, I'm just going to leave that there. This is going to be H plus Cl minus, plus this has to stay together. And the reason this has to stay together is because it's a solid. Mg2 plus 2 Cl minuses plus 2 waters. Again, the water will also stay together because it's a liquid. Now we cross off everything that is the same on each side. Well, what didn't work here? What's not working on this one? We needed to balance it. And then here's a 2 Cl minus. Here's a 2 Cl minus. I can't cross off the Mg because they're not the same. I can't cross the H because they're also not the same. So the only thing I can cross off here are these Cls. So then I'm just going to write the rest of this down here. And that's your net ionic equation, right? I'm going to put the state, I'm just going to put the solid and the liquid in here. Actually, I could probably put the AQ in here. So sometimes they look different. It's okay. As long as you follow that same formula, you're good. The thing is they have to cross off the exact same thing on both sides. So this would be your molecular equation. This would be the complete ionic, or again, sometimes called total ionic. This would be the net ionic equation. Okay, so let's try another one of these. Okay, so this one asks you to find the spectator ions and the net ionic equation from the following molecular equation. Okay, so just for a quick review, what kind of reaction is this?
Single displacement.
Yeah, single displacement reaction, right? So it's a single displacement reaction. And so now we're going to, first of all, break up all our AQs. Remember, we can only break up AQs. If you're not sure if it's an AQ or not, look at the solubility table, right? So that's going to help you. So we're going to break this up. I can't break this up because it's a solid. So sometimes it helps for you to like put a box around the ones you can't break. I can't break those because they're solids. So then obviously they're metal, so you can't break them up anyway. But sometimes it helps so you don't accidentally break it up in the next step. So now we're going to break all of our AQs up. So we have 2 Ag pluses, 2 NO3.
Shouldn't we balance it first?
What was that?
We balance it first?
It should be balanced.
Oh, okay.
Not ever a balanced one. Let me check. 2, 2, 2. Yeah, this is balanced. But By the way, if it wasn't balanced, you would be able to tell in this next step we're going to do. Cu2 plus 2 NO3 minuses plus 2 Ag solids. So when we look here, again, we cross off everything that looks exactly the same. Exactly the same. There can't be any different. Now, what do I mean by exactly the same here? This is 2 NO3 minuses. I'm not going to use a square, I'll use a circle. This is 2 NO3 minuses. Those are exactly the same. This is 2 Ag plus. This is 2 Ag solid. Not the same. This is Cu solid. This is Cu2 plus. Not the same. Do you know what copper looks like when you put it in water? Have you ever seen copper wires like from your headphones? That's what a copper wire looks like. And you put it in water and you know what it is? It's a copper wire in water. This is blue. And it's not solid, it's aqueous. It looks like blue water, but it's just copper in solution, right? They are not the same at all. So you can't break those up. So you can only take away the ones that are exactly the same. So in this case, we would take everything else down. So this would be our net ionic equation. Net ionic, this would be complete or total ionic. And this is molecular. Now the spectator ions, that's supposed to be Q. Our spectator ions, those are the ones we crossed out. That's our spectator ions. So NO3 minus, that's our spectator. All right, so we're gonna do another one of these.
Professor, on the last one, for like 2 Ag and 2 NO3 on the reactant side, is it okay if we write AQ when we're doing the complete?
Yeah, technically, yeah. So if I was gonna write this completely right, so you would write AQ. It's just really hard for me to do that from this. But these should say AQs after them. It's just really hard for me. So I mean, everything that doesn't say doesn't have like a symbol is an AQ. I'll try to do it on this next one. I'll just try to make it extra big. Okay, so now we're gonna try another one. So this time, same kind of question, right? And this time I have all of those states in there and I'll write the states the whole time. So I want you to try this one and then we're gonna go over this. Try this, I'll give you like 2 minutes and then we'll go over it. So remember when we're doing this is the molecular equation, the one we've been writing. The complete or total ionic, that's the middle step. The net ionic is the very last step, right? So there's 3 steps. So in this case, it's not asking you to do, it's just you have to go through the second one to get to the third one. Okay, so again, we're gonna break up anything that's AQ. You have to leave solids and liquids together. So this just states 2 NAs. And I am going to put all the states here. 2 waters has to stay together. AQ, AQ plus H2 gas. Okay, is there anything that is the same on both sides? And remember, exactly the same.
No.
No. There's nothing that's the same on both sides, right? So we're tempted to say, well, this is 2 NAs and that's 2 NAs. Are those the same? No. If you put this in water, it literally lights on fire, like actual fire on the water, fire. When you put this in water, nothing happens. They are not the same, right? Not the same at all. So even though there's 2 of them, the solid and the aqueous have very different properties. And so in this case, this is the molecular, that is the net, which that is. And the question is, what are the spectator ions? There are none. There are no spectator ions, right? So if you get a question like this and you're like, oh, I must have done something wrong. Not necessarily, right? Not necessarily. You've not necessarily done something wrong. There are these cases where your molecular, you break it apart, this is your complete and your net ionic equation. And there are no spectators. No spectator ions. Right? And so when you're doing these steps, you always, that's why we go through the 3 steps. First, you write the molecular equation. Then you break everything up that says AQ. Then you cross everything off that's exactly the same, right? The ones you crossed off, those are your spectators. We couldn't cross anything off here, so that means we have no spectator ions. All right, any questions about this?
For the product side, I had accidentally written, instead of the hydroxide together, I accidentally wrote 2O and 2H. Is that a big mistake when we're doing this?
Yeah, that's a great question. Yes, that would be incorrect because remember, this is a polyatomic ion. The polyatomic ions never come apart, right? And so think of this as an Na and an OH. So when it breaks apart, This is very different, right? Going like 2 O's and 2 H's, these are not the same. They are not interchangeable. So your polyatomic ions always stay together. So if you had like sodium sulfate, and it said like write the dissociation for this, then it would dissociate, meaning, so dissociation means when you put it in water, it comes apart. So what happens when this comes apart? So this would come apart into 2 Na pluses and 1 SO4, 2 minus. Right? So it would not, so the polyatomic ions, they never come apart. So sometimes it helps people to put parentheses around them to remind themselves they don't come apart. Okay, any other questions about these? Any others? Okay, that's the whole module / chapter. Any questions before we move on? Any other questions that anyone has before we move on? So you should be good for your quiz. Again, your quiz is the majority classifying and balancing with a few predicting products. Your exam's going to be the whole entire thing. Make sure you get that Chem 101 homework done because it's really going to help you, because there's a lot of details here that takes a lot of getting stuff straight, right? And missing one piece makes the whole question go wrong. So make sure you spend time on that Chem 101 homework.